Good morning, class. How's everyone doing today?
Good.
Okay, so last class I asked you to look up what a polymer was and to look up as many polymers as you can. So for our pretest journal activity today, I'm going to have you write down as many of those polymers as you can think of. Okay, so you got about 2 minutes to do that. Okay, so who can tell me a polymer that they wrote down that they found?
Wood.
Okay, that's a good one. What's another one?
Silk.
Silk, yep. What are some other ones you guys found? Any guesses?
Rubber.
Rubber, okay, yeah. So if you see on the bottom of your shoes, there's rubber. So almost everybody's shoes have rubber on the bottom, and that would be considered a polymer. This table is made out of wood on the top, but this bottom part, okay, so that's a polymer. What about your shirt? What's your shirt's made out of?
Cotton.
Cotton, okay, but what's another one?
Polyester.
Polyester, okay, so that word poly at the beginning, it's a key word here. Okay, polyester. What about plastics? Think plastic's a polymer? Yes. Okay, plastic's a polymer. Okay, so we're going to go through some notes real quick. Before we do that, the objectives for class is we're going to be able to draw a basic polymer, differentiate between a natural and a synthetic polymer, and then we're also going to be able to connect polymers to our everyday life. Okay, so to begin, polymer. So this first part right here, what does poly mean? Does anyone know?
Multiple.
Multiple or many? Okay, so then we have this in part, mer. Any guesses on what mer might stand for? No? Okay. Mer means segments or parts. Okay, so we have many parts that make up one thing. So a polymer is made up out of many monomers. Okay, so we have the same ending as we did up here. But mono, what does mono mean?
Single.
Single or one. Okay, so one part. So we have many monomers make up a polymer. All right, so as a class, let's stand up. Okay, I'm going to be the beginning of the polymer chain, and here's my connection. So I need someone else to be a monomer. There's one more monomer. How about another one? There's another one. Okay, so my hand's extending out to show many, many more, and your hand should be extending out to show many, many more. Okay, so we are a polymer, but each one of us is a monomer. Thank you. So if we were to draw that in a cartoon, we would have this long chain. Each one of these is a monomer, and then this whole segment here is a polymer. Does that make sense? Simple enough? Okay. All right. So now another polymer is polypropylene. Has anyone ever heard this word before? No? Okay. So I'm going to show you the Lewis structure of this. So we're going to draw a squiggly line to show that it continues going this way. And then we go CH2, CH, CH3. Okay, and then this sequence just repeats over and over again. CH2, CH with the CH3. Who remembers what CH3 stands for? Methyl. Okay. So one more. So line, and then what do I have to put at the end to make it continuous?
Another
Little-
squiggly
little
line.
squiggle. Okay, so another way to show how a polymer is you put brackets around the repeating part, and then you can have an N to symbolize how many times this segment is repeating. Okay, so this would be infinite times. Does everyone have this written down? Yeah?
Yes.
Okay, now we're going to talk about the difference between natural and synthetic. Okay, so when I say it's a natural polymer, what do you think that means? How's it made?
By nature.
Created by nature, just as the name says. Okay, so what are some examples that we've talked about in class so far that are a natural polymer?
Wood.
Wood,
Silk.
silk,
Cotton.
cotton isn't quite a polymer.
I thought you said it was earlier.
It's a polyester. Okay. So what about what you're made of? When somebody says in your genes, inside the nucleus, you talk about it in your biology class. Your DNA. Okay, so DNA is also a polymer. When we talk about DNA, what's the other one we usually talk about?
RNA.
RNA. Okay, so now synthetic. How do we think synthetic ones are made?
By synthets.
No. Okay, synthetic would be made by a man or a person. Okay, but what type of person do you think would make a synthetic polymer?
Scientist.
Or
Mad scientist.
yes. How about or an engineer? Yeah. Okay, so what are some examples that we've talked about?
Polyester.
Polyester.
Rubber.
Plastic.
Rubber, plastics. A big one when we talk about plastic polymers is PVC pipe. Okay, what is the coating called on your pans that you cook with at home?
Teflon.
Tef. Okay, so that's another big one. Okay, so if I were to give you the example of rubber, what kind of polymer would it be?
Synthetic.
Synthetic. Okay. Alright. So I'm going to we're going to do a lab. I'm going to give you a different type of polymer that you probably wouldn't think is a polymer. Alright, so what do you think's in this little bag here?
Funny.
I wish. Okay, as a matter of fact, it's a diaper.
Aww.
I know, okay? Does anybody have little brothers, sisters, or babysit? Dealt with one of these before?
Mm.
Okay, so inside the absorbents that sucks up all that waste from the body, is a polymer. So what I'm going to have you do is I'm going to have you cut open here, and we're going to pull it out and put it in a beaker, and then we're going to see how much water it will actually absorb. Okay, so I'm going to demonstrate. You can come close if you'd like. Okay, the polymer is safe to touch, but I would recommend not eating it. Okay? Because if you watch what happens to it in the beaker, you wouldn't want that happening on your insides.
Gonna happen to it in the beaker.
I guess we're gonna find out.
It's gonna explode.
That's cool. This is why I like chemistry.
Okay, so it's kind of a cottony look to it, and it's got powder beads. So I got about 500 mils of water in this beaker. This is going to fill a little bit of the way with the polymer. How much liquid do you think it's going to hold before it'll pour out? Before it won't absorb anymore? Think it'll take all this?
250.
250? I'm making a mess.
It's
Okay.
gonna take 150.
150. Okay, so we only have that much. If I squished it all the way down, probably only be about 100. Okay? So,
Take it all.
you think it'll take it all? So I'll pour a little bit in there. Absorbs all that. Absorbs all that. Okay, so how did we, what sort of diapers were used when, like, our parents were little? Does anybody know? Cloth diapers? Yeah, so those didn't have this fancy polymer invention in them. Those were just like our clothes. It was just a cloth that absorbed the moisture, but not as well as this. So we've used technology and synthetically made something that would absorb more liquid than just a cloth. Okay, so when we say that we've found a new discovery, it doesn't always have to be in computers or something technology-wise. It could be just for home care. Almost out. So it's increased in size as well, right? So that molecule is taking in the water and just expanding bigger and bigger and bigger. Okay, and it absorbed all of it. Okay, so we only had about 100 mils and it absorbed 500 mils of liquid. So that's pretty cool, I think anyways. So let's review real quick. What, if we were to draw a basic polymer, how would that look?
Looked like a bunch of boxes connected with lines.
You could even get more creative and you could do cats with their tails connected and whatnot. Yeah? What are some examples of natural polymer?
Wood.
Wood. What about synthetic?
Rubber.
Rubber. Okay, and then how does this apply to your everyday life?
Diapers.
If you have a kid, yeah, you would use a diaper.
What about old people? Don't they use diapers?
Oh, yeah, so you use them at the beginning of your life, and then near the end you use them again. Okay? Also, your water bottle that you drink out of, that's made out of plastic. Your shoes, your clothes, basically everything you touch every single day is made out of a polymer. Okay, so I want you to clear everything off of your desk. So on this sheet of paper, nothing else should be on your desk, right? I want you to draw a cartoon of polymer. It can be as simple as the one I drew in class, or you can use your artistic ability that I lack greatly and make something different. And then I'd also like you to name 5 polymers and state if they're natural or synthetic. We've named a bajillion polymers, so that should be pretty easy. Okay, so that's about it. I'll give you about 5 minutes to complete that, and if you get done early, you can read one of the articles in your packet.